This recording is based on assignment C number 33. It says a researcher was interested in the relationship between major and mathematics. Okay. What is the relationship? Is there a relationship between your academic major and your mathematics score? Okay. So he hypothesized that there was a relationship between variables, academic major, and mathematics score. So for this objective, the data is presented in the following table. You are given the task of testing his hypothesis by first completing the topic, research question, and the objective. So the topic here is major, academic major, and mathematics score. These are the two variables you are testing to see whether or not they are associated. So the question is there an association between academic major and mathematics score? That's what you're trying to test to see whether or not there is. So one may hypothesize and say, well, okay, there is. There is an association between mathematics, academic major, and mathematics score. So the objective now is to determine if there is an association between academic major and mathematics score. And to do that now, data must be collected. So here is the data that was collected. And here is your major, and here is the score. You have less than 60%, more than or equal to 60%. And the majors was what this was separated into natural sciences and social sciences. So according to this table, it shows that 40 students from the natural sciences scored less than 60%. 90 students from the natural sciences scored more than or equal to 60%. 70 students from the social sciences scored less than 60%. And 72 students from the social sciences scored more than or equal to 60%. So that's the data that has been collected. This is what was observed. So these numbers are the observed values. We have only one set of data there, which is the observed values. So the expected values now we have to calculate it by multiplying the row total times column total over grand total. So we have to get what you call the row total and the column total and the grand total. So let's do that. So as you can see, we have calculated the row totals, 40 plus 90, 70 plus 72. And the column totals, 40 plus 70, 90 plus 72. And the grand total is either 130 plus 142, give you 272, or 110 plus 162 to give you 272. So you can calculate the grand total either way. So now we can use that now to calculate our expected values. Now, as you can see, each observed value has its own row total and column total. So let me make a list of the observed values: 40, 90, 70, and 72. So these are the observed values. Now we have to calculate the expected values. So we need the row totals and we need the column totals. So the row total for 40 is 130. and its column total is 110. Do we see that? The row total for 90 is 140, and its column total is 162. The row total for 70 is 142, and the column total is 110. And the row total for 72 is 142, and its column total is 162. Okay? So therefore now, we can calculate the expected value, which is equal to row total times column total divided by grand total, which is 272. All right? Row total times column total divided by grand total. And we can control enter. So that will give us the expected values for each. And then we can calculate the chi-square contributions, which is observed minus expected, all squared divided by the expected. So it's O minus E, all squared divided by E. So for this one, there is O is the 40 minus its expected, which is in D2, all squared divided by D2. See, there was a problem. There it is. Open a bracket right there. Control E. Control enter, sorry. Oh, I did not square. O minus E all squared. So that's why I have some negative values here. O minus E all squared. Okay. So these are the chi-square contributions. And what I've got to do now is to add these up. Sum from E2 to E5. So my test statistic is 9.67. So as you can see, we have calculated the expected values and we have calculated chi-square contributions. We add it up, we get the chi-square test statistic. And as you can see in step number 7, we have to plot the test statistic on the distribution curve. The test statistic is 9.67. Let's get the distribution curve. As you do, it's always a right tail. Step number 4, 5, and 6. The critical value is needed. The critical value is 3.841. Zero. 3.841. And no test statistic is 9.67. 9.67 is greater than 3.841. So again, our test statistic is in the critical region. So we have to reject the null. Reject the null if the test statistic is in the critical region. And then we conclude, if we reject the null, then we have to conclude with the alternative. In step number 8, reject the null. We don't have to write these steps. Reject the null hypothesis. And the conclusion. So that's our decision. And the conclusion. We have to conclude with the alternative. What is the alternative saying? We have not stated our pair of hypothesis yet. That's a chi-square test for no association, chi-square test for independence. Here it is. The null is saying that there is no association, and the alternative is saying that there is an association. Right, in the calculation of the expected and the chi-square contributions, I forgot to state the null and the alternative. You must state the null and the alternative. For the chi-square test for no association, the null will be saying that there is no association. The alternative will be saying that there is an association. Now we have rejected the null because the test statistic was in the critical region, so we have to conclude with the alternative. Based on the data, there is an association between mathematics score, academic major, and mathematics score. These are the two variables. Variable A, variable B, academic major, and mathematics score. Academic major and mathematics score. That they are dependent on each other. So this is how you perform a chi-square test for no association.